The second section. The change to the parent function in item 1 is a vertical stretch by a factor of 2. And the change in item 2 is a vertical shrink by a factor of 1/2. A vertical stretch or shrink changes the shape of the graph. Number 4, reason quantitatively. For a greater than 0, how does the value of a in the equation g of x equals ax squared change the graph of the parent function f of x equals x squared? Well, if the value of a is greater than 1, it is a vertical stretch by that factor. If the value of a is less than 1, the graph is shrunk by that factor vertically. Number 5, a change in the position, size, or shape of a parent function is called a transformation. Identify the transformations that have been introduced so far in this activity. Well, in the last lesson, 30-1, we did vertical translation, We have talked about horizontal translations. And we just now talked about vertical shrink and stretch. Let's take a look at this next problem. Vertical stretching and shrinking also applies to linear functions. Below is the graph of the parent linear function f of x equals x. Graph the functions g of x equals 2x and h of x equals 1/2 x on the coordinate grid. How did these graphs compare with that of the parent function? Okay, so we're going to start at 0, 0. This says a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1. So this graph right here is g of x. Okay, let's now graph h of x. This one has a slope of 1/2, so it's up 1 over 2, up 1 over 2, up 1 over 2, like so. This is h of x. The graph of g of x is a vertical stretch, making the line appear steeper. The graph of h of x is a vertical shrink, making the line less steep. Take a moment to get this copied down and then move on to the debriefing question that follows. After you finish your debriefing, please mark this presentation as done.